Okay, we're going to add the last little bit to our science skills unit here. So we've built up all of the skills that we need to be a good scientist. We've learned how to make observations and build a good scientific design, experimental design with all the variables that you need. And now we're going to draw it to a conclusion by figuring out how scientists finally draw their conclusions from their experiments. What I want to start with is a little review. What you should be able to see here is, and I'm going to move myself, not sure if that works, is a Far Side comic. And what I want you to do is pause the video and read each statement and say whether the statement is a qualitative observation, a quantitative observation, or an inference. So go ahead and do that now in your notebook and then come back to the video. Okay, so hopefully you went through these and have some answers. So what I'm going to do is go over them quickly because we need to add a definition here. We have not officially gone over the definition of inference yet. So the first statement here is there are 7 books on the desk. Hopefully you said that was a quantitative observation. Quantitative observations deal with quantities, measurements, amounts. So we can count the number of books on the desk and say that there are 7. The woman is wearing eyeglasses. Hopefully you said that this is a qualitative observation, simply an observation about the characteristics or qualities of a person or whatever you're observing. And we can see that indeed she's wearing glasses there. Now, this one, the woman has just cleaned the desk. Now, we can make some observations here that would claim, that would support that claim. But it's not an observation in and of itself, right? So we call that an inference. An inference is a conclusion, a conclusion that you can draw based on evidence. It's not an opinion. It's not something you just came up with out of nowhere. It has to be based on specific qualitative and quantitative observations. And so here we can see that the desk is clean. She's looking at it. She has a little feather duster in her hand. She even says something like, now that looks better, everything's squared away. From that evidence, we could claim that she just cleared the desk and have a pretty good support to that evidence, or to that claim. Let's do this one. Einstein is trying to figure out a problem. Again, we have a lot of evidence that supports that statement, but in and of itself, it is not an observation. So it is indeed an inference. We can see he looks flustered. He's got some stuff on the board here. Things are crossed out, which indicates he might be doing some sort of trial and error. So we think, yeah, he's probably trying to figure out a problem. It is 10:30. Hopefully you said that that is a quantitative observation. A clock is a tool that we use to measure time. I know that this clock is not exactly right, but it is a quantitative observation when we take time. The woman has her hands on her hips. We can see that, qualitative. There is writing on the board. Again, that's qualitative. Even though there's numbers in the writing, it is a qualitative observation. And then finally, there's one piece of paper on the desk. That is a quantitative observation. So make sure you fill in the definition for inference in that vocabulary table. Then we're going to go ahead and move on. What we need to do now is, and I know I'm kind of blocking this here. It'll only let me have my video in certain places. What we're going to do is add the last little bit about making conclusions in science. So go ahead and either add to your former table, or you can create a new table if you don't have room. This little table where we have the term on one side and the definition on the other. That's what it says behind here. And then we're using these 3 words: claim, evidence, reasoning. Go ahead and pause if you need to, and we're going to move right ahead. So making a claim. So when we draw our conclusions in science, we need to make a claim as to whether our hypothesis was supported or not. So if I claim my hypothesis is supported, that is one conclusion. If I claim my hypothesis is not supported, that's another. In general, it answers the question. So if I created a hypothesis that made a statement and I said that that was supported, that answers my question one way. If I said it was not supported, it answers it another way. Usually a claim is just one sentence. We don't need to go on and on and on. You're simply saying the hypothesis that was supported by the data, or the hypothesis that was not supported by the data. And you don't include any explanations yet. It is just the statement. Okay, then we start to add the evidence. In order to make that statement, you must back it up with evidence. In science, the evidence that we use is the data that you collected in the experiment. And you can only draw conclusions based on that evidence. You can't say, well, this is what I got, but I think I did something wrong. You must draw your conclusions from your evidence. It can be qualitative or quantitative, but it must be specific. So you don't say, well, the data shows this. You would say specifically, you could see the growth from 7 centimeters to 10 centimeters over the 2-week period. Very specific. And only include the evidence that supports your claim, right? Again, you're not trying to provide any explanation yet. Okay? That comes next. So after backing the claim with evidence, and this is what it says here, it is important to explain why and how the evidence supports the claim. The reasoning is the explanation of why and how that evidence supports it. It'll include an explanation of the underlying science concepts that produce the evidence or data. Okay? This is the trickiest part. Okay. I'm going to show you an example here, and I can't move that, but I'll talk about it in a second. For example, here's just a made-up test. So it says the hypothesis that chewing gum during a test increases test scores was supported by the data. There's my claim. I'm simply saying that my hypothesis was supported by my data. Now I'm going to use my evidence to back it up. Here's the evidence directly from my experiment. During the trials, the test subjects chewing gum scored on average 30% higher on their math test than those not chewing gum. The highest gum chewing score was 100, while the highest non-chewing score was 87. So I have specific numbers, specific evidence that directly supports my claim. And now I'm going to attempt to explain it, provide some reasoning for it. Therefore, I could use some transition words there, like this suggests chewing gum clearly increases concentration in test takers, which allows them to focus on the test instead of being distracted. That is my backing it up. I'm reasoning that based on my evidence. We're going to get to this a little bit later and what else you might include in a conclusion, but I wanted you to focus on the claim, evidence, and reasoning first. What you're going to do next is a little example, and then you're going to move on to drawing conclusions from your own experiment.